Let us consider the same example, but the inequalities have changed to less than to greater than. So the solution may be as like same in the previous manner. There is no restriction of greater than, less than, or like that. So first of all, we'll equate the we will convert inequalities into equations like this, and then similar process. We are finding the values of x1 and x2 simply by substituting. First x1 value is 0. By substituting x1 value is 0, we will get x2 value as 6. So the x2 value is 6, and then x2 value will be 0. 3x1 plus 0 is equal to 6. 3x1 equal to 6. x1 equal to 6 by 3, and then it is 2. So the values are 0 and 2. Next we will substitute the values in 4x1 plus 8x2 is equal to 16. First of all, x1 equal to x1, x2, x1 value will be 0. 4 into 0 plus 8 into x2 is equal to 16. 8x2 is equal to 16. x2 is equal to 2. Now x2 will be 0. By substituting x2 will be 0. 4 into x1 plus 8 into 0 is equal to 16. 4x2 is equal to 16. x2 is equal to 4. Next we will substitute these values in the graphical form as shown in the below. So the values of x1 in the first equation, x1 value is 2, x2 value is 6. So put in the values. x1 is 2, x2 is 6. Draw the line like this, and then in the second value, x1 is 4, x2 equal to 0. x1 is 4, x2 is 2. So draw a line like this. Now when we come into the inequalities are greater than or equal to. When the inequalities are in the form of greater than, then the region bounded by this equation will be outside of the origin. Similarly, the region bounded by this graph will be outside of the origin. The points are plotted in here like this, but it is not a closed region, it is an open region. Then simply we can write it as, we can only have a unique solution if and only if it is a closed region. Since it is not a closed region, therefore we can write it as there is no feasible solution, like that. Hence this problem is completed. If in the same problem, if the inequalities are like this, the procedure may be the same. 3x1 plus x2 greater than or equal to 6. 4x1 plus 8x2 less than or equal to 16. In the same procedure, for example, the graphs are like this. This is first equation and this one is second equation. Under the first equation, the equation's inequality is greater than. That means the line passing through the points are like that. In the second equation, the line passes are less than. So the less than here will be less than like this. The 2 points are bounded in here itself like this, in the form of a triangle, the region. So the coordinates will be for this region is 1.5, 1.5, 2, 0 and 4, 0. As you can identify them in the graph sheet. So after finding these values, this is a closed region, then the problem has the solution. After finding these 3 points, as we discussed in the previous problem, you have to substitute them in the values of maximum z, 3x1 plus 2x2. So 1.5, 1.5, then z is equal to 3 into 1.5 plus 2 into 1.5. The value will be 7.5. At 2, 0, z is equal to 3 into 2 plus 2 into 0. The value is 6. At 4, 0, z equal to 3 into 4 plus 2 into 0, then 12. Therefore the max value of z is maximum at 4 comma 0, therefore x1 equal to 4, x2 equal to 0 and z value equal to 12. This is the required solution.